Okay, so let's start. Okay, today it's quite close to the Chinese New Year festival. Okay, so I try to finish today's lecture around 11 past 10. Okay. Very low attendance rate, right? So at this moment, I think we have around 20 students. I mean, selecting this course, but currently, okay, low attendance rate. But before we start, I still wish to quickly go through the teaching plans. So this is week 2. And next week we don't have any classes due to the Chinese New Year festival. And in the actually it's going to be week 3. We are going to introduce the unmanned autonomous system. And from week 4, okay, just in one go to the deep learning and the conventional machine learning stuffs. And week 7 we have a lab sessions. So lab sessions is still here. Okay, take your laptops. And week 8 we have midterms. That's going to be based on what we have learned from the past 6 weeks. But still, I want to say in this course, okay, 80% is about machine learning and deep learning. 20% is about the unmanned autonomous system stuffs. Yeah, I try to cover. So last week I have collected expectations from you guys, and I try best to cover all the things you wish to learn. And from week 8, okay, week 9, we are going talking about the supervised learning. Okay, especially for the CNN. And from week, okay, let's say it's holiday. Okay, no lectures and 2 weeks for case study. And unfortunately, we need to have a makeup because we need at least 2 weeks for the case study. So this is roughly for a teaching plan. And also you can find the source files of the teaching plan from the Blackboard. So in here you can find, this is, okay, this is the guidelines for the Gen AI. Okay, so you need to refer to this one for your information. And for the lecture notes for the lecture one, you can find this in the Blackboard. Okay, I will update the slides frequently. For example, I make some revisions or updates on the slide. Please refer to the latest slide for each week. And for week 2, so for this week, we are, okay, start with Python. So you need to take your laptop and for teaching plan, okay, you can refer to this one, okay? So this is the finalized version of the teaching plan. So from week 1 to week 13. So I think all of you have taken the laptops. So last week we are talking about the fundamental concepts of the machine learning. So I think last week we have finished the page. We have finished this conclusion in the 38. So in last week we have preliminary trial linear regressions and logistic regressions with Python code. Okay, at least in my laptop. So with the help of ChatGPT, we can quickly, recover the code or get the code for the logistic regression in minutes. So in the last week, we have mentioned the basic concepts of those old machine learning techniques like a linear regression. So that's suitable for the simple linear regression cases. So for example, this is two cluster of points, right? Two cluster points, and this is red part and this is blue dot. So this is the boundary, okay, to discriminate the two different clusters. So because this boundary is linear, okay, so that's why this is called linear regressions. So the problem of the linear regression is given two sets of data. So at the beginning, you don't know what is the parameters of this straight line, okay, the boundaries. So you need to do a regression process, okay, to obtain the parameters of this line. Okay, this is going to be a line fitting problem. So in the coming lectures, we are going to provide the principles, the mathematics behind. So for this is another problem, you see. The boundaries between the two clusters is not that linear. So of course, this is a linear case. So you need to figure out some other solutions to find the binary to discriminate to different cluster points. So this is a logistic regression process. Okay, to discriminate, okay, to different clusters. And the logistic regression suitable for the nonlinear regressions, especially if the boundary is going to be typically nonlinear, obviously nonlinear. So the decision tree is going to be, this is quite rule-based. Okay, it's quite easy to understand. But still, in the coming weeks, we are going to provide the principles about the decision trees. So, for example, if you are doing research on, on some engineering problems that requires the general classifications, okay, so this decision tree can be a good case. So last week we have mentioned the filtering of the spam email and hand email. So decision tree can be a good solution. So there are a lot of nodes. Each nodes going to make a decision based on different rules. And the supporting vector machine. So this complex high dimension nonlinear regressions. So for example, this one, okay, the boundary is highly nonlinear. So the k-means is unsupervised learning. So it means there's no ground truth, there's no labels. Okay, so this is for the k-means. So given no number of clusters, okay, this is a requirements. So to conduct or to implement, okay, the k-means clustering, you need to provide the number of clusters. You need to let the algorithm know how much how much clusters you're going to do clustering. So for example, okay, upright. So this is example as you have different cluster of points with different colors. So this is just a summary of what we have done in the last week. So the schedule for today is going to be, we finish the introduction of those deep learnings and a little bit about the latest AI algorithms, for example, transformers, okay, brief introduction. And later on, we are going to move to the Python, okay? So like 20% for the introductions and 80% for the Pythons. So this is the schedule for today. Deep learning. So deep learning is a branch of machine learning. So last week I mentioned, so deep learning is a technique to implement the machine learning. So deep learning is a branch of machine learning and artificial intelligence. So in terms of the classification, okay, on the top, AI, okay? A program that can sense, reason, inference, and adapt. Okay, on the top is AI. It's quite clear, right? So in the middle is machine learning. So machine learning is algorithms whose performance and improves as they are exposed to more data over time. For example, in the last page, the summary, okay? KD-trees, K-means, SVM, so regressions. So all those methods are belongs to the machine learnings. And for deep learnings, so this is what you expect most in this course, right? So deep learning is mainly is multi-layered neural networks learn from vast amount of data. So for example, the ChatGPT, okay, the large language models. So those are trained based on a lot of sequential data. Okay, for example, from data from books, from internet. So this is the classifications. So AI is nowadays considered as a core technologies of today's fourth industrial revolutions. So for example, like NVIDIA, okay, the GPU is currently the major facilities for doing the trainings of those networks. So even I cannot remember, maybe the NVIDIA currently is the second biggest company in this world. Okay, you see the power of those facilities for the AI eras for those training stuffs. So okay, fourth industrial revolutions. Okay, fourth industrial revolutions. So the artificial neural networks. So this is learning from the melanated axon chunk. So for example, like this, and emanated from this, we get an artificial neural networks. So for example, those are neurals, or those are connections, neurals connections. Okay, the detail for those principle of the neural networks will be also introduced in the coming weeks. But generally, you need to know, okay, so the neural networks is going to be like inputs, outputs, okay, different layers of neurons. For example, okay, this is a single layers, right? So in the future, maybe multiple layers. So more layers, more connection, deeper. Deep neural networks, deep learning means have more layers and they have different connections. So for each the connections, they are delivering, conveying the informations within all those connections one by one, okay? So for example, if you have a lot of layers, like 10 layers, for each layers, if you have like 100 neurons, okay, you can consider how many connections you are going to have. Okay, if all those neurons are fully connected means this neurons is connected with all the neurons in the coming layers. Okay, it means each connections you are going to have one more equations. So for example, if you want to train the networks, okay, you're going to have one equation plus a lot of equations. That's why the training process is a computational heavy problems. So if you use the CPU, it's going to be a problem, right? So the GPU can do the acceleration to do the parallel computations. So that's why it can be efficient. That's why NVIDIA is going to be the second largest company in this world currently at this moment.
I mean, this, and this are also recognizable as 3D, even though the specific value of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves for you as representing the same idea, while at the same time recognizing other images as their own distinct idea. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this and outputs a single number between.
So at the beginning, for example, this is the 3, right? Capture, okay? So in front, if you take image, okay, you get a binary image, okay, you get a lot of numbers corresponding to this image, right? It's like pixel values. So feed this into image.
Unless you've been living under a rock, I think I probably need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here.
So for example, if you want to classify, okay, this capital is 3 or it's 8. So typically you have like several solutions. For example, you use the machine learnings. For example, all machine learnings that support the vector machine stuffs. And also another way is deep learnings. Of course, you know deep learning is going to be more accurate, right?
It shows you what neural networks actually did, but giving no background. And to help visualize it.
For example, like a 3, okay? 3, capture 3, okay? So what you get from image is a series of pixel values. So for example, okay, directly you can feed all those pixel values as an inputs, okay? Go through multiple layers, you get a results. Results say, okay, this is 3, let's say letter 4 or 8, 9. So this is the results, right? So generally the concept is like this.
Not as buzzwords, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivating, and to feel like you know what it means when you do or hear about a neural network, quote unquote, learning. This video is just for you to.
So the learning is going to be, for example, I just mentioned each of the connection, okay, is delivering or encoding some informations. It's called weightings. It's called weightings. So the training process, okay, you feed the data to the networks, you're training the data. So this process is to learn the weightings, the values of this connection. So for example, okay, after the training process, for example, the large language models, okay, usually we say this model is pretty big. So what the model includes, the major information the model includes is a series of weightings, a lot of parameters. So this parameters is represented by each connection. So each connection is some weightings like from 9 or 0, 1, 0, 2 stuff, different weightings. And because as you know, deep neural networks, a lot of layers, a lot of neurons, it's going to be a big and a deep networks. You have a lot of parameters, right? Like 10,000 billions of data, 10,000 billions of parameters for each of those weightings. So this generally the main concept.
The following impact of learning. What we're going to do is put together a neural network that can learn to recognize handwritten data.
So of course, if you get more data, I mean, if you get more, okay, in terms of the data, okay, if you get more data sets and get more high quality data and more advanced algorithms, for example, in terms of the design of networks, you have different designs, right? So it's going to have different performance. So what the research is doing is design different efficient networks. So for example, if you want to design lightweight, so for example, we have a lot of UAS. So in this course, we focus on drones, right? UAVs. So if you want to design lightweight networks to be applicable for the drones, you need to make sure everything is lightweight. Okay. Also, maybe it's like a trade-off between the accuracy and efficiencies. Accuracy and efficiencies. We need to make a trade-off because for the drones, it's different for the cars. For self-driving cars, we have big batteries carried in a car. So for the drones, you have very limited batteries. So you need to make a trade-off. So as I just mentioned, for example, okay, from the computer side, okay, feed to the computer is an image, okay, as the inputs. So the neural networks, you train this, okay. A lot of connections, you get the weightings, you see. This is a dense networks, right? A lot of connections in here. So later on, output is the results. This is the same, okay. This is input.
This is a somewhat classic example for introducing the topic. And I'm happy to stick with the static focus because at the end of the two videos, I want to point you to a couple of resources where you can learn more and where you can download the code that does this and play with it on your own computer. There are many, many variants of neural networks, and in recent years, there's been sort of a boom in research towards these variants.
So the convolutional neural networks. Okay, this is going to be introduced as well. So this is very good for the image recognition or the classifications. So for example, okay, later on, okay, you're going to try the Euro, okay, to use your laptop to do detection of the different objects. Okay, this, for example, based on the convolutional neural networks. So the second one is the long short-term memory networks. So this is for the speech recognition. So for the image recognitions and the speech recognitions. So what's the difference? You can you can consider in your mind, appear in your mind. What's the differences? Think about this. Image and speech. Yes, yes, yes. This is one point. Yeah, good point. Any more? So you mean different frequencies means the time series or just one snapshot information? So what do you mean by frequencies? They have different components, right? Different components with different frequencies. Yeah, that's a good point. Any other points? Yes. So the first point is of course, for I mean for image, it's like it's an image. So actually in the image processing society, they can also analyze the different components with different frequencies with the image as well. One of the major differences is image is image. It's from 1 second. It's one snapshot information. But for the speech, IN Dr. Wen. So this is sequential data. If you just, I mean, recognize the speech with just one snapshot data, it's maybe not enough. But the speech, each of the characters, they have the connections or correlations. You see? So the first one is image is like a snapshot solution. But for the speech recognition is like considers a series of data. So that's why in the coming slide, we are going to talk about a lot of solutions called recurrent neural networks, RNN. So this can consider the sequential data. Okay, sequential data to improve the, of course, you can consider very long sequential data. So the job X is going to be the high computation load. Okay, so this is also a trade-off between accuracy and efficiency as well.
But in these two introductory videos, you and I are just going to look at the simplest plain vanilla form with no added fiddle. This is kind of a necessary prerequisite for understanding any of the most powerful modern variants, and trust me, they still have plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, we'll see how it does fall short of a couple hopes that we might have. As the name suggests, neural networks are inspired by the brain. But let's break that down. What is a neuron, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of these 28 times 28 pixels.
So 28 multiplied 20 by 28 is a small size, but actually, in fact, I mean, it can be a big size. So for example, if you take an image for your smartphone, it can several times more than this.
784 neurons in total. Each one of these holds a number.
So I mean, the most stupid way is like you directly feed those 784 features to the networks. Okay, that's most stupid way. Okay, so that's going to be a big impulse, big size of instance of size of impulse, right? So this is going to be big size.
That represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network.
Okay, project into vectors.
This has 10 nodes, each representing one of the digits. The activation in these neurons, again, some number is between 0 and 1, represents how much the system takes that a given image corresponds with a given digit. There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question. So how on earth this process of recognizing digits is going to be handled? In this network, I chose 2 hidden layers, each one with 16 neurons. And admittedly, that's kind of an arbitrary choice. Yes, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experimenting with a specific structure. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network I'm showing here,
so just for different numbers, is going to be the similar concepts for the detection. So generally, okay, the impulse, okay, series neurons and different layers, okay, the outputs. Okay, so in the later lectures, we are going to provide the details and principles. So this is definitions. Okay, the tensors for the convolutional networks is similar to the previous one. So later we are going to have, I mean, at least one lecture to specifically talking about the CNN, okay, convolutional neural networks. Because currently I mean, pipelines like the Euro is all based on those CNN networks. It's very fundamental parts. So make a quick comparison for those conventional machine learning and those deep learnings. So several parts. So the first one is the feature engineering. So for example, in the last week, we have a question. So last week we have a question in class question about, so what are the typical features, okay, for those spam emails, right? So we have make those questions. But for the conventional machine learning, for example, use the decision trees, okay, to detect the spam emails. So you need to know, okay, what is the features? You need to extract the features, okay, manually by yourself before you use the machine learning techniques. So this is for the conventional machine learning. So traditional machine learning often requires the manual feature engineering. So this is the point. But for the deep learning, so particularly neural networks, can automatically learn the features. So for example, in the previous page, okay, directly feed all those pixel values with like 28 multiplied 28 is 786 something to directly to the networks. Okay, so don't need to do the feature engineering anymore at this moment. Particularly neural networks can automatically learn the features from raw data. So raw data means the image, for example, the digits, the image from digits. So because currently we have a lot of, for example, for the detection of those digits, okay, it's already a very well-studied problem. So, okay, a lot of open source data sets, you can use those labeled but open source data set to train your models. It's quite straightforward. So in this case, from raw data, reducing the need for the manual feature engineering. So this can be beneficial in capturing the complex patterns in the data. So especially if you have the big data sets. So as you know, if you want to get good performance, you need high quality data in terms of quality and quantities. Lots of data, right? So if you want to train a lot of data, you need to label the data. For example, if you use machine learning, you also need to manually do the feature engineering. So it's going to be a lot of works. So this is one of the comparisons in terms of feature engineering, okay? So for the complexity and the flexibilities, so machine learning models like decision trees, okay, support vector machines, SVM, and logistic regressions are generally simple, much simpler, okay, and may not capture complex patterns. So for example, if you are talking about some complex detection, so for example, later on you try the Euro stuff, right? So Euro for the detection of different objects. So this is complex stuff. So if you use conventional solutions like SVM for detection, it's not going to be convincing. Okay, accuracy is not guaranteed. So for deep learning, so these models can capture more complex nonlinear relationships in the data, so which might be beneficial for detecting sophisticated spam tactics. So I'm not sure if you have done a news from AI field, the DeepSeek. You know what is DeepSeek? Of course, you know the ChatGPT, right? So previously we think, okay, so if you want to train a large language models, okay, so even you based on the lemma, for example, open source the large language models, if you want to train this, you need to be rich, you need to be have a lot of monies, okay, maybe several billions of US dollars. But recently, okay, a company in mainland China, they open source a DeepSeek. You guess how much money they spend to train a large language model? I mean, to the DeepSeek is you can think, okay, this is another ChatGPT. So how much money they spend? You can think about this. I'm talking about the complexities. Only 6 million US dollars to train a model, and the open source. For example, previously, okay, maybe like 2 years before, okay, you use the ChatGPT, you have some limitations. For example, you can only ask very limited questions because of limitation of credits. But it's because the ChatGPT is quite expensive. But currently, okay, if you use a DeepSeek, it's more than cheap you can imagine currently. So because for the DeepSeek, okay, another ChatGPT from mainland China, okay, they largely reduce the complexity of this model, even the size and the complexity for training. This means in the future, it can be possible, but because I mean the things in this field they change almost every day. Maybe tomorrow it's another DeepSeek is coming, so I mean it's going to be more and more smaller size. At least the last year, I never think about we can deploy the large models to the drones because the computation power and battery is limited. But from at this moment, I think it's possible because someone is doing similar stuff like deploy the large models for drones. Because drone, at least we can see drone is what it can represent the future. So okay, a lot of drones can fly to do a lot of unlock a serious applications. So it becomes possible to deploy the large models for drones at this moment. So the last one is the adaptabilities. So machine learning may require more frequent updates and manual tuning to adapt to new span tactics. So it means, for example, if you want to increase your generalities of your models. I mean, machine learning models to different problems or different data sets. Okay, you need to do the frequent tunings. But for those deep learnings, okay, generality is going to much better, can potentially adapt better to new patterns, okay, without the separate reprogramming given the enough data. So this is a comparison of the conventional machine learnings. Okay, of course you'll see, okay, a lot of benefits from the deep learnings, right? I didn't point out the drawbacks of those deep learnings, okay? So what do you think is the drawbacks? Okay, flip classroom. So what do you think is the drawbacks of the deep learnings compared with the machine learnings? Okay, interaction. So any ideas? Sorry? Yeah, included. The second part included already, right? So for example, okay, so in the future, if I deploy the large models to the drones, right? What is your biggest concern? What are you going to worry about? What is your biggest concern? For example, if you take a flights, commercial flights from Hong Kong to San Francisco, so what is your biggest concern? Exactly. Safety is the biggest concern. So last week we have mentioned the machine learning is interpretable, explainable. You know what happened in the front, in the behind, okay? You know everything in the behind. The model is quite clear. So for example, if you deploy the large models to the drones, get crashed, who to blame? Okay, so because you all know like if you have the large models, it's black box. The larger, the more blacker. Okay, the black box. So you never know what happened in the front. So that's why the Stanford, okay, for example, like firstly, they have established a research institute, especially working on the safety of the AIs. Safety, okay. So safety is the biggest issue to be one of the biggest issues to be tackled, especially to do the massive deployments of those deep learning methods for the US, for drones and for the cars. So another one is, okay, recurrent neural networks. Okay, recurrent. So the main features for this one is, it's like, it's talking about the sequential data. So for example, for the speech recognitions we have mentioned. So the longer speech, usually it's much easier for you to understand the reasons behind, right? Longer speech. But the problem is longer speech means more data, okay, to process. That's going to be much more difficult, more computational heavier, okay? So the recurrent neural networks are mainly used to process the sequential data. For example, the speech recognitions, okay? And are able to capture the temporal, okay, temporal and sequential is kind of similar stuffs. Dependencies in the data. For example, a lot of data I like speech. Okay, this is Dr. Wen. So you see all those, okay, captures they have the letters, they have the correlations in between, dependencies in between, right? Even you use different languages, they have dependencies in terms of different words, different letters. So this are used for the sequential data. So the advantage is processing the sequential data. So for different problems, okay, of course you need to, for example, today you are working in a team, no matter you are in a company. So uh, also what I want to say is just one thing appear in my mind. I have a very strong impression in my mind, especially in the past several years. So as you know, Professor Li Feifei established a startup company in San Francisco, right, in US. So do you know what's the reason behind? Think about. Don't talk about money. Okay, money is one of the point. So what do you think is the biggest point in the like I mean behind this initiative? I mean, establishes personally Fei Fei is a very famous professor, okay, working on the machine learning and deep learning stuffs. Okay. So what do you think is the reason behind to go to the industries to he I mean in US usually you can have 2 years of sabbatical leave. Okay, you keep a position in the university and you can go to industry for 2 years, then you can go back. So she established the stock counting. So what do you think is the major reasons behind? Besides the money in past, think about this. Several points, just my personal thinkings. Okay, so one from points is so in the universities, especially you are talking about the deep learnings. Okay, you need to have a lot of GPUs, right? So for example, if you are in a Stanford, okay, you say I a big professor, I have secured big amount of funds. Okay, it's 2 millions. Okay, or maybe 20 millions is it's big funds, but compared with the companies, it's just a small amount of money. Yeah, you can only buy maybe 10 GPU cars. But if you want to train the big models, especially when you're talking about the sequential data, okay, this is one point. They need okay, personally, they also need to have the GPUs. Another point is like I have a strong impression in my mind. So especially we talking about those AI and unmanned autonomous systems. So like industry-wise, for example, companies like Google, they also have very strong research team. So previously, I mean like 20 years before, we talk research. It's about university academias, right? But currently, it's like since it change, we need to open our mind to look into the society. Actually, the industry they also do a very good job in the research. That's why you have AAE. We need to open our mind to the society. They also do a very good research, do a great job in the research. For example, for Google, they have a lot of labs. I personally, if you also want to go to industry to see how industry looks like and how they do is covers, for example, given the same problems. Okay, given the same problems, how the different industries look into the problem from different angles. For example, if you take the mathematics, usually question and the teacher will tell you, lecturer will tell you one solutions. But if you go to societies or you go talking about the engineering problems, okay, usually you need to look into the problem from different angles, from different angles. I remember maybe Sahad, in my last course, I have questions in my assignment. One first student used 40 different solutions to solve problem. I look into the solution in detail and he get a full score. I forgot the name of the student. So it's different angles. I solve the problem perfectly. So that's what I want to say is like deep learning industries, they already do a very good job. We need to, but what I want to say is for academia and for the industry, they have different strengths. For example, if you are academia, okay, working on deep learning, we are deep. Because we're working on a very specific topic, we dive into this topic several years. We are deep. But if you want, because I mean, this research for a deep learning is different. You need to have a lot of money, a lot of people to label the data sets. You have a lot of GPUs, okay, train models. Industry's question in this part. But what I want to say is we need to open our mind to the society, to the industries, to different research teams, and to collaborate, okay, to maximize the strengths from different teams. This is what I want to say. Even if you like for example, if you get a chance to AAE, okay, try to do this. Okay, maybe just my sharing, okay, for information. Maybe if you go to start with your AAE, you may have some different thinkings in the future. So the disadvantage is for the RNA's long dependencies problem. For example, like it may rely on a long sequence data. For example, for the speech recognitions, okay, if you want to get good performance, maybe it relies on very long series data, okay, long speech. So this can be potentially the advantage, disadvantage. So low condition efficiencies, okay, still it depends on the size of your speech data. This is some examples. Okay, for example, the translate. So I'm not sure if you have tried. I mean, I have make a comparison in terms of the performance of the Google Translate. Okay, Google Translate currently is quite powerful. I mean, currently quite powerful. But if you make a difference between, make comparison between the Google Translate from at this moment and the one in the 2017, okay, 2017 I start my PhD, right? So it's very different in terms of the accuracy and the performance of the translate, Google Translate. So Google Translate is one of the examples that use those similar techniques. So the text generations, okay, text generation, for example, okay, just like text generation is, okay, let me show you the examples for those text generations. Okay, you must be quite familiar with this one, right? So for example, the ChatGPT, okay, it can generate a text. And okay, upper right is this is from mainland China. And okay, from Meta, okay, let's see one for the open source part. So this is text to image. Text to image is slightly different. So RN can use it for the text generations. And the speech recognitions, I would say the speech recognition is one of the most successful case. One of the most successful case. And the time series forecasting and the video captioning generations. For example, like as I just mentioned in the ChatGPT page, we can do the text to image generations. So generally, it's going to be like the sequential is errors. So the errors represent the sequential connections between different timestamps. So for example, ST-1 represent one timestamps, and the sequential data fed into the recurrent networks. Okay, make this to be a sequential problem. So I have received the most success when working with the sequences of words and paragraphs and even for speech, generally in the field of natural language processing. So actually in our university, so we have a new faculty. So the computing previously this is department of computing, right? So currently we have a new faculty. It's like so what's the full name? Data science and applied mathematics something. So see, so in our department of computing previously we have several very famous professors working on the natural language processes. So this is for the text generations. So for example, giving an image, okay, generate text. Okay, the man in black shirt is playing the guitar. So girl is pink dress is jumping in air. So there's a dog, generate the text. So this game is like technique, I mean, should be developed in 2019. Rinse is correct. Again, the game is developed in 2019. I mean, again, should be around 2019, developed in around 2019. So the generative adversary networks, as the name suggests, consist of generative and the discriminative networks. Okay, two different networks. So, okay, no need to really understand the details, right? You just understand what is the key features of the game. Okay, game is kind of very, for example, okay, we have the games, we have the cycle games, then we have the transformers. Okay, the backbone of the ChatGPT. So you can understand, okay, the game is kind of very new techniques. So the training, okay, let me try to explain these equations, okay? So in these equations, we have two parts. Okay, the first part is to minimize the G, okay? The first part is to, so the first part is to minimize the G. So G is the generative networks. Okay, use this image. Okay, money. So for example, okay, it includes the two parts. The first one is the generators. The second part is the discriminators. So for example, this is a classification problems, right? So generate the data. So the network will generate data. So, I mean, when doing the training process, okay, the network will generate the data to as it has to be as close as to the real data. Okay, generate the data. But actually, this one is a fake data. It's a fake data. So it also increases discriminators to discriminate this and ground truth. It means it's kind of like attack with itself, okay? Try to generate the fake data and also tries to discriminate the fake data and the ground truth data. Ground truth data is a real money, okay? So in terms of those two parts, okay? It tries to get the base performance in terms of the generators. It tries to generate the based image, that is the same as the real data. So for a discriminator, it tries to maximize the discrepancies, the differences between this one and this one. So based on these two concepts, okay, we have two cost function. So the first one is G, second one is D. So we try to minimize the error from the generators. And we try to maximize the cost function from the discriminators to discriminate the fake data and the real data. So the general concept is like this. So this is a recursive solution. I mean, so you minimize this one and maximize this one. Okay, simultaneously to train the data sets. So the result of the training is the networks, the gain networks. So this is a general concept. It tries to attack with HR, okay, itself, okay, a generator and a discriminators. So if you want to know more details for the updates of this technology, you can refer to this group paper, So anyway, so currently I talking about gain, right? So a lot of variants of these gains. For example, the next page is going to be the cycle gain. So cycle gain is another. So general pipeline is, okay, you get noise generators to generate image, and discriminators tries to discriminate this and the real data So the cycle gain is another one that is, okay, this one is another one is the cycle gain combines, the cycle gain is, so the cycle gain is another solution. It's like a high level gain. So the cycle gain typically use two generators and discriminators. So in the previous one, we only have one generators and one discriminators to achieve the gain. So the idea behind it is image A is fed into the generators. For example, we have two images. This one is fed into the generators, and it generates a certain image A, and the same image GA generated from image A is fed into another generators to reconstruct the original image FA. It's like a recursive process. It combines two generators and two discriminators. This is the applications. Okay, so let's take a look. This is, I have a satellite image. Okay, if I have a satellite image, so I want to generate the lane lines or the boundaries of those buildings. Okay, you can train again networks to achieve this. So this is input. So the upper image is the lane lines and the boundaries of those buildings. Okay, so this is input of the gain, the output of the gain. So another one is, for example, like for denoising cases. Okay, this is a noisy cases. Okay, after you use the gain, you train the networks, you can get a much clearer, high resolution image. And okay, this one is like changing the colors and designs. So okay, let's say another one. This is quite powerful. For example, if you want to design a bag, so you just need to sketch the boundaries, outlines of the figure and feed into the gains, you can get the results. Get results. This is example. I'm not sure. For example, if you use a ChatGPT, okay, from GenAI from PolyU, okay, of course they have the text to image. This is a translation problem. Okay, let's see a translation problem. Take break for 10 minutes. And also you can take try on the examples here, okay, in the slide. You can try this one. So this is examples for the detections, okay? You can try this one. You can get the slide from the rebels, okay? This one. Oh, I think I have hide the slides. Okay, so attention. So let's try this. So this is hands-on examples to use use the tester Euro. So Euro is a very famous open source networks to do the detection of the objects. So okay, let's take a look. This is a collab. Okay, you can refer the slide. So it should be page 52, page 52 in the slide. So you can find the slide from the Blackboard. And also you can find the slide from this GitHub link. So this is a GitHub repository. You can find AAE4011. Okay, S2 means semester 2, 2425. Okay, so you can find the lecture slide and also the code. So first, please open this link. Okay, open this link and collab. Okay, collab, as we mentioned previously, this. Okay, I need to show you what is collab. So collab is this is a hosted. Okay, maybe in the coming lectures we are going to introduce the collab again. So it's a hosted Jupyter notebook service that requires no setup to use and provides free access to computing resources, including GPUs and TPUs. So this means with free service to share the CPU and GPUs from Google. So Colab is especially very suited to the machine learning, data science, and education. So first open this. So open this link. Okay, you're going to forward to the Colab and you can log in this with your, so I think you all have your, at least you have Google accounts, right? Google Gmail. So you can log in with the Google Gmail. And then you can click this one, okay, the code. Okay, click the code. Click this one, okay, click the code. And you can find the code, okay, in lecture slide, find the source code at this one. Issue 2, okay? Also, there's a collab link here, okay, you can click this link, it's the same. And okay, there's a copy, okay, copy the code. Copy the code and copy the code to this. Copy the code to this code block and okay, so at this moment you don't have any image, right? So if you look into the code, it's quite clear. Okay, at the beginning, okay, let me try to explain the code line by line, right? At the beginning is import the get Python and import the display. So this is different toolbox. And import the torch. The torch is deep learning network libraries. And first it will input the model of the Euro. Okay, Euro v5. Okay, later I will introduce you what is Euro. So the first one, you need to change the parse of the image, change the parse of image. So from left side, okay, there's a button here to upload the Anifast to the session. So I will upload the image. I will upload the image. For example, this is image from our lab. And okay, I just change the name. Okay, change the name to, so the content is the left side. Okay, this is the parse of the content. And the lab JPG. And okay, this is the original image. So this is original image. Okay, for example, like a lot of people's, okay, there are some rooms, there are some cars, subject cars, different equipments, right? So there's a button, okay, it's like a play button here, okay. Okay, click this one, okay. It will, okay, you can see some output here. It will like download something, download some libraries. Okay, download some libraries. Okay, everything is in a Chrome, right? In a website. Everything is done in a Chrome. So take a look. It's still installing something. Okay, you can see the outputs. It's executing. Okay, executing. Okay, one moment. Okay, take a look. Your attention. Okay, so this is the results of the detection. Okay, this is the results of detection. It's like, okay, person. Okay, for example, this one. Okay, Dr. Bai. So 0.73. Okay, this is percentage of the confidence in terms of this detection. Usually it's more than 0.6 or 0.9 or 0.6. It's a plausible detection. Okay, okay, detection for. And also, if you can see, there are some cars. Even a car is like partially blocked by the different people's, still detection is around 0.4. Okay, so that's the detection result. So take try. Okay, take try. And for example, I upload my results. Okay, you can see I upload my results to the GitHub. Okay, so you can copy and paste and upload your result to the GitHub. So take try. And if you have finished, okay, please upload your results to here. Okay, just copy your image here and comment. So later on we can see your results. Okay, take try. Okay, if you have finished, upload your image to this issue blog, then I can see your results. Okay. Let me know, and we have two TAs here if you have any questions. This photo is quite fun. No, you don't need to delete the content. The first level. Okay, just copy and just revise the name. Okay, for example, you don't have the image, you can download my image and change your name. For example, change the name to lab.png something. Okay, for example, you can download my image, scrolling down. Okay, you can download copy. Okay, right click and download the image. Yeah, and change the name. So when you change the name in the code, you don't need to delete the parse. So your attention. So when you change the name, you only need to change the name. For example, my image is lab.jpg. Okay. So for example, in your image is a JPG or JPG or PNG. So change the name and keep the first level of parse content. Okay, keep this. And the results will save to this to left side with this image. It will also be visualized on the button. Okay, this is the results. For example, you can if you don't have image, you can take image. Okay, you can take image outside if you wish. Okay, take any image because anything. For example, you can see for example chairs, desk, projectors also can be detected by Euro by this networks. So if you have any questions, let me know. And okay, we have two TAs here as well. Oh, Louis, this is ready, right? And also for for example, if you click the profiles, okay, this is uploaded by Louis, right? So if you click into this profile, okay, you can see the details. For example, okay, like Louis is also, yeah, at least those repositories open source to us. We can see all those repositories. Like in the past years, in the past week, in past, month, you can see some, actions, interactions of Louis on the GitHub, upload something. I'll get 2 stars for the James tours, right? And 2004, what's this? This is year one lectures, right? Oh, I see. Get 4 stars. It's good. Okay, so yeah, so please upload your results if you have finished. Upload the results. Let me take a look. Okay, one more results. Oh yes, you can download any image from website. You can do the detections. Also, you can take an image in this classroom. It's also okay. It's fully okay. So when you get a image, I mean, if you get a results and try to save the image with different with some other formats instead of the PNG. So I have tried to upload the PNG image to the GitHub, but it seems doesn't work. So what my solution is, I translate the format of the image from JPG to other formats. Ah, this is Hong Kong, yeah. Because you can easily find some translators. Okay, translate the image format from JPG to from PNG to JPG from Google. Yeah, this is 1, 2, 3, 4. Okay, we get 4 students finish. So okay, let me try this again. So if you're still not yet finished, you can take a look again. So okay, the code is, I mean the source code is, okay, you copy the source code from this issues, okay, from the link. Okay, if you get the code, okay, copy and paste. And copy and paste, you need to change the name, okay? First, you need to upload the image. Upload image from the left side, okay? Upload the image. For example, upload the lab. For example, this one, okay? Upload image and change the name to LK Edge. 9.5. Okay, keep this content. Hit the first levels of the cars. And then, okay, left side, there's a play button or running button. Okay, play. Okay, click this one. It will start to process the image. Okay, process the image. This is another results. So this is my previous image with taking drones, right? So this is okay. This is very real thing. So this is laptop, and chair, and okay, different drones. Okay, this is the mistake. This is the same. So I maybe this is the same one. This is the mistake. So this part is not included in the pattern of the training reaction of this model, this neural model. And this is person, and the other P also the method. Okay, one more. Yes. One more. Perhaps. Let's see. Total. Oh, for example, Sahaj. Okay, click into the profile. I can see. Okay, I can see the profile as well, right? And also for this one, can also see the profiles. Okay, so let's know repositories. Yeah. So as I mentioned to you last week, the GitHub page is a very protected. 1, 2, 3, 4, 5, 6. Okay, 6 only. Okay. Question. Okay, so let's move on to the next part. Eight, nine. Wow, this airplane is also included in the data sets, right? Okay, that's good. So question. So for example, if you, okay, if I think about 10 years before, right? 10 years before you have developed this state of the ant algorithms and what do you think can be potentially the applications of the euro, for example? Any ideas? The first thing I can see is like I already know some from universities they have a cameras in the front and look into the classroom to silent attendance. No fake attendance. There's the camera just in one go and collect the data. Of course, they will delete the data after the class. At least they can sign attendance. Okay, if you are a company and if you are the first one to do this, of course you can make money. Also, you can use this euro, use the camera to the intersection with the camera to count the number of the cars, the density, the flow, traffic flow, to monitor the traffic flow. This is the open source networks. Of course, I mean, if you are talking about the internal version from a company, of course, the accuracy is even much better, right? So you can see a lot of, I mean, potentials can be unlocked by this Euro algorithms. So if we get into the code, okay, you see, we finish the, I mean, we finish the results, we finish the, I mean, practice or let's replicate this demo just in 1 minute. So at the beginning, it's from IPython, import the Python, get the Python, and the display. So install the PyTorch and import the torch. Torch is a network, neural networks, I mean, open source pipelines. So let me stop sharing. So you can find a lot of information from PyTorch. So this is open source the neural networks. I mean, open source pipelines libraries for example, if you do a neural networks, related research, AI research. So this is a very open, very popular pipelines. And Euro. Okay, so Euro is open source pipelines. Okay, it's based on the CNN convolutional neural networks for the detections. So currently a lot of different versions. I'm not sure what is the latest. Should V8 something? Euro V8, the latest version. Euro V8, 11. Okay, 11 already. So you see, I mean, this pipeline is updated day by day. So this is a very famous open source pipeline, and a lot of papers as a, I mean, inputs from should be actually ICI. This is a conference from robotics. Okay, gradually improve ICC, ECCV. So this is European Computer Vision, says computer European. What is it? First C, ECCV, computer European EC. This is one of the basic conferences. Computer vision. Okay, European computer vision conferences. So this is for a euro. This is for a euro. And also you can try more data sets for, actually this is coming from the VIS, the visual June data set, a lot of image in this data set. So later on, if you want to try more, you can, I mean, download image from the data set and to take try on different image. So in terms of the code I just mentioned, so the first one is, so just one line. Okay, you can load the existing Euro V5 version 5, okay, model. So this is I mean, if you do the large scale training, so the results is this model. You load this model and set up the parts of this image, and later on you get a results. So this is image, and this is results. So this is results, and this is the plot results. Plot results, show results. Okay, so this is for the results of this image. A lot of cars. Okay, so let's move on. Yeah, as just mentioned, for for the Euro, okay, you can see a lot of applications for like sign attendants to monitor the traffic flows. Those are different applications. So what is drone? So for introductions, we have two parts. The first part is talking about the AI and the machine learning and deep learning. So we are going to talk about unmanned autonomous system. For example, we focus on the drones. So what is a drone? So the drone have a lot of components. So for example, they have the propulsion system, power system, mechanical system, control system, perception system, sensing system. For example, sensing means different sensors, right? So this is example from DJI. So, cause for different tasks, I mean, the drones can unlock a lot of applications, right? So for different tasks, the sensors, the computation power, and the algorithms is going to be different. For example, this is for the drones for rescues or some delivery cases. So the sensing system may be different compared with the drones. I mean, working in the city areas. So this is the typical setups of the drones. So we have a lot of sensors, right? For example, like we can have the, so generally, okay, basically, we have the mechanical systems. Okay, it means the structures. For example, mechanical structures of those, the propellers, rotors, engines. So second part is called the electronic systems. We need to have the microcontroller units, right? MCU. Okay, electronics, and also we need to have SoC, system on chip. For example, we need to have the NVIDIA computer in the streams. And last one is the algorithms, the software. So for example, the Ubuntu system to operate, to process all those data from different sensors, right? So three different layers, three different layers. So in terms of the sensors, okay, so typically we can have the GPS antennas and stereo camera. And okay, so in this is a sensor, I mean, sensor abundant cases that have lots of sensors, right? We have like stereo cameras and the uh, this is M pixel. This is another model's cameras looking to the ground. So also for the direction determination, we need to have the magnetometers, okay, to determine the headings and the orientations of the streams. And also if you have two antennas, we have redundancies to determine the headings of the drums, okay? So also the PC board usually can be I mean, it can be a microcomputer from NVIDIA, for example, microcomputer from NVIDIA. So also we can have a Wi-Fi antenna for testing purpose. Question. So which part of the streams you think can be assisted by the drones? Oh, sorry, by the AI. So for example, okay. So for example, if I want to make the drones to be autonomously deliver a parcel, okay, from polio to UST, for example, a medicine, okay, medicine drug, urgent medicine drug. So the first part is you need to know where you are. This is perception cases, right? Like determine your positions like with GPS or camera stuffs or 5G, 6G. And second problem is to understand what is in your front and what is the optimal path to there. So this is about the scene understanding and planning cases. The last one is the system control by wire. For example, you need to control rotors, propellers, okay, to approaching a destination. So basically, we have three different components, right? So which part you think can be assisted by the artificial intelligence? For example, we have the positioning, we have planning, control, and even in some complex applications, you need to make a decision making. For example, if you're talking about swarm intelligence, you have a swarm of a fleet of drones. You need to do decision making styles. For which part you can see, think about. For example, you can use the drones together with Euro to detect those like traffic flows, okay, right? Just flow and hovering, and take image in the front to monitor the traffic flows. Mm-hmm. Sorry. Yeah, that's right. That's right. But the problem is like always we try to use the AI. Of course, you can say, okay, we can use the AI to improve it, but we need to make a trade-off between accuracy and efficiencies. Because for example, for drones, we have only a very small battery. That's why your DJI drones have only like 20 minutes of the maximum durations to fly. So we need to make a trade-off in terms of the AI and the accuracy and performance. Of course, you're right. So each of those one can be assisted by the AIs. For example, if you have cameras, we need to do the perceptions, detections. We need to have AI to do detections, right? So for localization, like GPS can be assisted by the artificial intelligence as well, and also for the prediction and tracking, and or even for the controls, we can, for example, if you want to make some very high dynamic motion control of the drones, you need to have usually the researchers tries to use the deep reinforcement learning to improve the accuracies, especially when you're talking about high dynamics motion controls, motion controls. Even for the communication, so this can be assisted by the. Oh, just one more thing. Okay, so this year, so probably you have a lot of research institutes in mainland China, right? Currently, to extend the impact of PolyU in terms of knowledge transfer. So how many research institutes we have in mainland China? You think? Any ideas? So we have 15. We have around 15 translational research institute in mainland China, including Shenzhen. Like, okay, actually I working with a research in Wuxi Research Institute. So in in September, so we are going to host the competitions. It's called AI plus Jones. So we are going to host the competitions, AI plus Jones. So this competition is going to be invite the different teams, international from different nations. So if you have interest, just let me know. Okay, you can join this competitions. And we have cash awards. Cash awards. Okay, we have big sum monies for the cash awards. The topic is AI for drones. It's AI for drones. So this is a question I just mentioned. Ask from you. So the first one is what AI can help with drones. So the first one is adaptive path planning. Okay, adaptive path planning. This is one that the drones can, for example, how to do optimal path planning and so for example, okay, so existing path planning problems, we already have a lot of methods, right? Like A-star algorithms, random forest, RTT stuffs. So why we still need to use the AI to assist the path planning? Because we should not say, okay, this is a problem. You can use AI. This is a problem, use AI. So why? What's the reason behind? There must be some challenges in the front, and we use AI to solve it. That conventional model cannot solve it efficiently. So why? Any ideas? Yes. 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 Yeah, exactly. So especially when you have very limited sensing capabilities. For example, you don't have the map of the terrains, like you only have image. That's why, for example, if you go to go hiking, right? You have camera, have image. Okay, you can do the path planning, roughly do the path planning. So this is one point. Any other ideas? So for example, when we do the path planning, for example, in you have take the ENG to I forgot the name. So one of the components in the course is about path planning, right? So conventional path planning only considers the shortest path, shortest distances to approaching the destination. But in practice, we need to consider a lot of different factors, a lot of different constraints. For example, the terrain information, the acceleration, the suitabilities, for example, for the drones or for cars, the suitabilities, and the energy assumption, energy consumption, all those factors need to consider. So that's going to be a big decision-making problem. It's not only a path planning problem, it's going to become a migrate to a decision-making problem. So if you leverage the AI, it's going to be do much better decision-making considering different factors. So this is, generally one of the angles in terms of the reasons why we need to use the AI for artificial intelligence. So AI for the path planning. So another one is the detection of the drones. So for example, this is the example we have just replicate with euros, okay? With euro to do detections. And also AI can use it for assist the GPS positioning. So as you know, GPS cannot be reliable in urban scenarios. So actually we have to quite a few works on the how to leverage AI to dive into the models of the GPS. So for example, how to detect those reflected signals, all those stuffs can be kind of assisted by the AI, by the AI. So this is another case is with a transformer. Okay, transformer is you can consider this is another networks for detections. So especially in some of the cases, this is duck, right? So for detection of different agents. Okay, so let's see another case is like use this is a network developed by this paper. So this is for the detection of the US attack. So for example, if you take the GPS sensor, okay, in the drones. So now the GPS is sensitive to the sensor tag. It can be easily attacked by some spoofers. We call this is called the sensor spoofing or sensor attack. So the problem is like the sources of the attack can be quite diverse. Okay. So in this case, how to detect the spoofings from some hackers or attackers? So let's run for another potentials from AI. So use artificial intelligence to detect the spoofings. Okay, this is another applications. So of course, to do this, I mean, the pipeline is quite similar. So you need to have the data sets, you design the models, and then you train the models. Design the models and you train the models. Yes. Okay, so this is going to be moving to the next part about the Python. So the tools for learning the AI is including some libraries and also including the Python programming. So take break for 10 minutes. So you can start this repository just in case you cannot find it. You can start it. Oh, I cannot because I didn't log in. No problem. Yes. Yes. What's your question? Mm-hmm. Ah, yeah, sure. You can translate the because this is a PNG. Ah, this is PNG or JPG. Oh, no, no, no. This is still PNG image. So can you show me the source file of the image. Show me the image. So because the format of the image is a PNG image, but since at this moment you cannot upload the PNG to this GitHub, so you need to translate the image from PNG to JPG format, JPG image. And since that you only change the name, but here is it's still PNG. Essentially, it's still PNG. For example, you can search online. For example, change image. Okay, you can find a lot of tools. PNG to JPG. No problem. Okay, so let's move on to the later slide. So, okay, later on, all the, all the codes, applied in this, introduced in this course will be archived in this repository. Okay, later on, we are going to have a new folder. It's called codes, example codes. You can refer to this page. And also, if you have any questions, because some of our students, for example, if you have some challenge, have some questions in terms of preparing code, or for example, in the maybe next week we discuss about the details of the different Python programmings. Okay, any questions? Feel free to raise questions in here. Okay, so raise questions in here. Okay, flip classroom. This is also part of the flip classroom. So we need to collaborate to help you to learn. Okay, to programming. So the basic solution to learn programming with Python is to practice. Okay, let's not short pass. Okay, practice, practice, practice. Okay, so let's move on to this part. Oh, one more thing. Okay, before we finish today's lecture, okay, I want also take this image to say, okay, great chance new you to you and families. Okay, so this is our lab. This is our first year we design this. Okay, with the drones. Just now I tried to feed this image to the Euro, so nothing happened. So I mean, Euro cannot detect anything. For example, this satellite, this is cars cannot be detected by the Euros because those are not trained by the Euro before. Okay, so this is the image. Let's go back to the slide. Okay. So because of the time limitations, I think today we cannot finish everything about the Python programming because but still you can just I mean assume we can finish the programming with Python by next week. Okay, by next week. So before we start, I still want to introduce some very general tools for you to learn the programming with Python or learn the programming with Python for AI. So the first part is some toolbox for the networks. So generally, the Python is integrated and object-oriented. So any of you have taken some classes from computing before programming with Python? Any? It's from computing, right? It's from which department? It's by Dr. Wang Bing. Okay, it's specifically for Python. So for what I mean, what is included? Like dictionary, list, and some control function. Sorry. Oh, origin. I see. I see. So any examples like, for example, what is I mean, you should have some labs, right? So what is a lab about? It's like plotting something or solve some mathematical optimization problems. Kind of project. So let's say the compulsory course or all of you have learned actually, right? Okay, I see. That's great. So Python is integrated. Okay, just quickly go through this one. So Python is an integrated, object-oriented, high-level programming language with the dynamic data structure. Oh, sorry. What about C double plus? No, because I mean, if you want to really understand like US, as I mentioned, we have 20% for the unmanned autonomous system from system wise, and like 80% for the artificial intelligence. For 80% is based on the Python programming, right? So 20% is about like C double plus. So for example, you mentioned last week about SLAM. Of course, it's not going to be done by Python because low efficiency. So it's based on C double plus. But still, I will try to introduce the ROS to you. Okay, so in the next week, if I have time, I will introduce the robot operation system to you. So besides the Python. So also you can take a look first before next lecture. Okay, you can take a look on the ROS as well. Ah, yes, I know. But later he going to talk about ROS for the LiDAR slam. For LiDAR slam, we need to have the C double plus. Yes, yes. So this is ROS, robot operation system. So this is a very famous project before, previously coming from Stanford. It should be from 2009 something. Okay, from Stanford University. So this is also a class project. So later on, it's developed continuously and it becomes a very general operation system for robotics. So I mean, if you wish to learn more for this one, I will introduce a little bit for the ROS in the next week. For example, those keywords like DGPS, Path Planner, this is a big community as well. Lots of open source work can be found here. So if you want to know more about ROS, and you can make some preparation first, okay? Next week, I will introduce a little bit, make some preparations. So the Anaconda. So Anaconda is open source package and environment management system that runs on Windows and Mac and Linux. Install, run, and update package and the update dependencies. So usually, for example, if you have a problem like you have multiple versions of Python, for example, the first package, for example, you're working into different projects. The first project requires the Python 2, version 2, and the second project requires the Python 3. So it's going to be a conflict in your laptop. So Anaconda is a good software or platform to manage the different versions of Pythons. Of course, there are some other functionalities, but generally, it can be used for the management of multiple versions of Pythons. Okay, Jupyter. So just know the Colab is also based on the Jupyter. Jupyter means you can, okay, you can run a lot of codes directly from the web. It means you don't need to install any IDE. For example, VS Code, you don't need to install this one. So the Colab is also based on the Jupyter. Okay, this is three toolbox or the platforms. So Python is become more and more popular in the society, okay? Become more and more popular in society. So basically the C double plus. So C double plus is really popular, of course, because a lot of, high level algorithms are based on the C double plus because C double plus is quite efficient, especially when you're talking about some very complex optimization problems. For example, nonlinear optimization problems, the C double plus can be very efficient. And of course, C, like some operation systems like the Linux operation system. The kernel is based on C. So Java is for developing some AP applications via smartphones and C sharp. So okay, the Python is okay. This is Python. Okay, okay. It becomes the rank at the first by around 2024. Yeah. So Python has become more and more popular in society, not only for artificial intelligence and also for the data science, for the data analysis, data mining. So for anacondas, I just mentioned to you, so there are different distributions. Okay, this is for Jupyter. Okay, Jupyter is, this is quite easy to use and it can do some programming, not only for Python. Okay, Python is only one of the applications. So for example, like Jupyter, this. Okay, later on you can try this in your laptop. Okay. For example, this is an example to plot these figures. Okay, just copy the code. So this is an example code to uh, so this is example copy in my Python code for how to want. Okay. Use this example as a copy code you can put. So for example, this is example to start figuring variable calculate and so for the given function here, that will file what you have. It's crazy. For example, if you like do some analysis and you want to do some quick analysis. For example, if you're doing searching that's from data, for example, from camera or from PDF filing, you want to do some quick analysis. The result. Okay, for example, if you want to plot the results, you can just click this one. Okay, you can get the results. And if you change something, like change this to 8, it's going to get different random variables. Maximum is three dimension. Okay, so this is Jupyter. and some toolkits. For example, a matplotlib. So this is a library to plot the, plot different figures. So to this is the research one. I think so the multi-function is I think for example, matplotlib can solve anything for data analysis. And also can, okay, some GF is also can be done by Python. So based on different projects, for example, we do, uh, so this is some example codes for the matplotlib. If you copy the code to the method to the Python, of course you will see that is some result. From 10 functions to 10,000. So pandas. So pandas is introduced in Python code before. So pandas is this is a powerful process for the analyzing of the structural data. So that can be used to quickly implement the data in and out indexing. So pandas provides the type of classes for handling data as the series and data frame. So this is all. This is the data analysis, data frame, data analysis. This is all. There is one dimension table array styles. So NumPy. So NumPy is, oh sorry, the pandas is a library for the data analysis, and the NumPy is the metrics. Okay, NumPy is the metrics. So NumPy should be NUM should be numerical Python. For example, MATLAB is metrics lab. That's why it's called MATLAB. So numerical Python NumPy. So this can be used to do other things. For example, like also we find out that for land and for like a land, we also find out probably about Python. Of course, there will be based on the NumPy, which is the metrics calculation. So keywords for NumPy is metrics and calculations analysis. Okay. So scaling is a library to the machine learning. So for example, in the last week we have okay, so now microLink. Okay. So if you remember, you have examples. So this is examples like, okay, one side of a different question code. Generally, so in here, okay, so the concept left on the given concept of the question, and this is math of the data. This is also the result. And it also data relies on the data with NumPy and that. The data and the NumPy also relies by this data number. Okay, so this is the given. So one of the upfront high topic is in phase 5. So since the deadline is kind of use the
generate example to what for this line. That's another example. But for the next one, also generate the example following comparison of that problem. And the market modeling like for plotting. This is Panda. This is for data frame processing. And on high, this is for math calculation. And also in this table, there are a lot of different methods. For example, the method for concentration. Okay. For concentration cases like the technical machines. And also for clustering, also all of the methods are implemented in the data analysis. So the keras. Okay. So just now we implement the neural. So the neural is implemented in so keras is another important from the language for implementing the deep learning networks. So keras is a deep learning API. Okay, written in Python and capable of running on top of AeroJX, TensorFlow, or PyTorch. So first contact with keras. So the core data structures of keras are layers and models. So in this course, we may mainly focus on the so not all things that is interactive or maybe one mode existing platforms. Let's say example. This example I forgot to one to this is one mention for so this is a comparison. This is almost, I mean, so TensorFlow is also very popular. So TensorFlow is so yes, TensorFlow is from the economy. Oh, okay. So TensorFlow is also very popular, especially when when I start my PhD. So TensorFlow at that time is very popular. So PyTorch, TensorFlow is from Google. So PyTorch is built by the Meta. Okay, Meta produced by Facebook, produced by Facebook. They are research lab and built on the Torch library. It's first released in 2016. So of course, it's based on the different frequencies, based on your properties, and you can select different libraries. Okay, so I think that's all for fundamentals, concepts, general instructions for the different libraries, and also have some bucket and a little bit about so that's it. That's it.
I see many of you are going to, I mean, maybe catch your flight or catch a train for that the whole time. Okay, for you to take a little together. Okay. Okay, yes, thank you. Okay, that's all. Yeah, thank you, thank you. Next questions?
Which system?
Ubuntu. And also Ubuntu will be installed during the class, no worries.
Okay.
It's quite efficient. We are going to use some like virtual machine styles. 2004 something.
22 or 20?
2004 something.
Oh.
20. Okay.